Hey, I'm Peso and welcome to the first cubing video on this channel. Core magnets are the latest craze in cubing hardware, started by the GAN 11M Pro all the way back in 2020. They've made their way down to excellent mid-range cubes like the Guhong Pro, and also into big cubes starting with the X-Man Hong, and recently the Vin 4x4 also got a core magnetic upgrade. If you're wondering what core magnets or magnetic ball cores are, they work by providing a magnetic pull between the corner feet and the core of the cube, stabilizing the cube through more of the turn than a regular magnetic cube. Depending on the radius of the ball core and the strength of the magnets, they may also give some amount of auto alignment. For example, this custom 20 magnet ball core Worm V9 has quite a lot of auto alignment, whereas this QiYi MS with a ball core has virtually none. Or you could have something more in between, like this other Worm V9 that I have with the regular 8 magnet ball core. Some cubes even have repelling edge core magnets for even more speed during the turn and more auto alignment, again, like this cube. Now, I've always been interested in cube modding, so when I returned from a break from cubing over a couple of years, of course I wanted to make my own core magnetic cube, and that is what this video is all about. Before I move on to the next part of the video, I'd just like to take a moment to give a shout out to the Geo 3x3 document and the comprehensive hardware guide. I've had the privilege to work on both documents and with the amazing team behind it, and we believe these really are the best documents in the world for learning and improving at 3x3 and choosing which hardware is best for you. The document has sections on general improvement, the CFOP, RU, ZZ, and even APB methods, among other handy tips. The hardware guides has multiple lists for WCA cubes and lists for non-WCA cubes, as well as a lube and setup guide to help you out when choosing those things. I'll link these in the description of the video, and so be sure to check them out. To cut a long story short, I ended up stumbling across this Reddit post recently while I was researching how to make my own core magnetic Worm V9. The link will be in the description of this video, by the way. This is a really great resource that has 3D printing files for a large number of cubes, all tested and with instructions. I should note, however, that when in doubt, go with the lower magnetic strength on the magnets that are in the instructions, or even lower than is suggested, because the stronger magnets would definitely be too strong. I used a local library's 3D printing service, and it cost me about 20 Australian dollars or 13 US dollars, including the magnets for a 20 magnet core. That has 40 magnets, 20 for the core and 20 for the pieces. If you choose an 8 magnet core, so that's 16 magnets, it would cost around 15 Australian dollars or 10 US dollars. You may even be able to find cheaper magnets and a cheaper printing service, hence the title of the video. I recommend the 8 magnet core as it's not as strong, but nearly as stable. You'll also need some super glue and some hobby model clippers or wire cutters like these, but you might have these lying around the house already. Another note, if you want more of an auto alignment feature on your cube, do go with the 20 magnet ball core, as the 8 magnet doesn't really do that unless you specifically designed it so that the radius of the ball is very small. All you need to do is to make sure your magnet polarities are correct. So you could do this by taking a magnet off and sticking a piece of tissue paper in one end so you know that you're pulling from the same end every time. And then, or you could do this by taking the magnet you want to glue and then attracting it to the already glued corner piece and then pulling it off so that you know it's the correct polarity. Then you take that magnet and you put some glue like this. I'm using Gorilla brand gel super glue. I'm not sure that I would recommend this. Probably the liquid one is better. But you would take this, put some in the magnet slot, and then take your magnet and press it in. I won't actually do it because I don't want my magnet to get stuck. Then you take this ball core with all the magnets inside it and put it around the core of your cube. It should be noted that you can technically do this mod without any 3D printing, but it gets very messy and very tricky to do. I found this out the hard way with my beloved MF3 RS3M that I attempted to core magnetize. So the corners ended up okay, but the core ended up not okay, and as you can see, it's very messy. This Worm V9, on the other hand, looks really great and was extremely easy to put together after trimming off the excess plastic from the 3D printed ball core. The result is a very stable cube with very strong but rounded feeling magnets. I would probably recommend going with magnets weaker than suggested on the instructions though, and I personally think this cube needs the maglev for speed. That being said, I do like very fast cubes like the Tornado V3 Pioneer and the original Worm V9. The 3D printed ball core is the route that I recommend to most people as it's simple and easy to do. I hope I've given a good explanation of how to core magnetize your cube. Anyways, onwards with... Now comes the interesting bit, making a custom kit. This takes time and effort if you don't already know how to use 3D CAD programs, but it's also very fun if you're into this sort of thing. First of all, I recommend you download Autodesk Fusion 360, as it's a very user-friendly program. If you're a Linux user like me, you might want to try FreeCAD, but if you're also impatient like me, you'll find that it's quite a bit harder to use and learn. I devised the following method from a variety of sources. This video on core magnetizing the GAN-X, Rabid Rubiks, thanks again man, and the Reddit post I mentioned earlier. You'll need some calipers to measure your cube, so thanks Jeff for letting me borrow yours. Take note of every single internal dimension that might be relevant, as you'll need to make a very accurate model of your cube's core. The most important dimension is the maximum ball diameter, taken by the distance between the center of one torpedo to one on the opposite side of the core. I made my core using 3 cylinders, 3 square prisms, and a bit of trial and error with Pythagoras' theorem, but eventually I got to this product. I then put a ball around the core with dimensions that would fit without interference, and the ball inside to make that one a shell with thickness of 2 millimeters. I then subtracted the smaller ball from the bigger one, then subtracted the core from the hollow ball using the cut tool. This is mainly to make the ball lighter and faster to print. I used 4x1 magnets, so a thickness of 2 millimeters for the shell was sufficient. Something I found after printing was that the slots for the core wings weren't quite deep enough, so I had to remove some material. If you have these slots, be sure to make them deeper and wider than initially when you subtract the core from the shell. Making magnet slots was the hardest bit. I won't show any footage of me attempting to punch holes in the ball because there was a lot of trial and error, and it took me almost a whole day to figure that one out. I haven't quite worked out how to do it better. However, the best method I've come up with, that I've heard of, is you make a sketch of a circle with diameter of your magnets, then rotate the ball so that the circle is in the correct position, and then extrude the sketch into the ball to create a pocket for the magnet. Thanks again Rabid Rubiks for this tip. You can then slice the ball in half, do some filleting, and apply a mesh to make the curve smoother, and voila, you have something ready to print. I'll now speed through some footage of me gluing together the core. I've now spent a couple of days with the cube, and I can say that the mod was totally worth it. My chosen magnet strength was perfect and gives the cube a moderately strong magnetic bump without too much change to the pleasantly fast speed. It's much more stable now and doesn't feel squishy like before, but retains just enough flexibility to be fluid. The only downside is a more inherent problem with the cube's design. The reverse corner cutting is a bit snappy and catchy, but tightish tensions and lube really helps with this. It's also not good for rough turners, as the catching can lead to corner twists or even pops if you push a corner while the cube is locked up. I set up mine with Gravitas, FZ Calm, Weight 1 and D&M. This dampens the clacky sound and makes the cube's hard plastic feel softer. I should stress again that these downsides are more the cube's fault rather than the mod that I did, so I still wholeheartedly recommend that you try this mod on your cube. If you've made it this far into the video, thank you so much for listening to all my nerdy yap. Don't forget to like and subscribe, and I'll see you in the next video. That next video will probably be music related, so sorry to disappoint all you cubers. Anyway, bye.